Hello everyone, welcome to Smart Insight. As you have seen in the thumbnail, today we are going to discuss about some of the coding questions which are asked at Candela Technologies. So without any delay, let us go for it.
So this is the problem number one, and let us try to solve this. So read this entire problem once. I will directly tell you with an example. But before that, you pause the video and read the entire problem. Here we have two arrays. The first array is G and second array is S. Let me take some inputs like random inputs like 1, 5, 3, 3 and 4, and S is 4, 2, 1, 2, 1, 3. So this G array refers to the children and S array refers to the cookies. Means this one refers to the grade factor of child 1. This 5 refers to the grade factor of child 2. And this 3 refers to the grade factor of child 3. Similarly, this 4 refers to the grade factor of child n. Here n refers to len of G. Here this 4 refers to the length of cookie 1. This 2 refers to the length of cookie 2. Similarly, this 3 refers to the length of cookie n. Here we have used n, right? Let me make it as m. M is len of s. Okay. So what we need to do here, we need to distribute these cookies to these children, but the condition is they should get satisfied. So what is the criteria for making them satisfied? If you are looking for that one, here is the we need to maintain this condition s of j greater than or equal to g of y. Since, for example, here is the cookie of length 4 and here is the children 1 whose grade factor is 1. If we assign 4 to this one, he will get satisfied because 4 is greater than or equal to 1. Because we have already assigned this 4 to 1, we should not use this 4 again to any other children. So here is that condition, each child at most one cookie. Okay. And then we have 2, 5, we should not assign, 1, 3, we should not assign, 2, 3, we should not assign, and 1, 4, we should not assign. Here we have 3 and here we have 3. Because 3 greater than or equal to 3, we can assign. So in this way, we can able to satisfy 2 children here. Okay. But the problem is we need to maximize the number of children who got satisfied, right? So that depends upon how we are distributing the cookies to the children. So is there any optimal approach? Let us see. Here what we are doing is we are assigning this 4 to this one. Means we are simply wasting 3 cookies here. So what if we assign the smallest of this one to the smallest of this one? For example, 1 to 1. There will be no wastage of cookies, right? So the idea is to sort the array. Like if I sort this array, it will become 1, 3, 3, 4, 5. And if I sort this array, it will become 1, 1, and 2, 2, and 3, 4. So let me consider pointers here. Let me consider I and j. Let me check the condition. S of j greater than or equal to g of phi. 1 greater than or equal to 1. Yes. So we will increment both I and j. Is 1 greater than or equal to 3? No. We will only increment j. Is 2 greater than or equal to 3? No. We will increment j. Is 2 greater than or equal to I? 3? No. We will increment j. Is 3 greater than or equal to 3? Yes. We will increment both. Now is 4 greater than or equal to 3? Yes. We will increment I. Since j crosses its limit, the loop will stop here. Okay. So what is the position of I in this array? 0, 1, 2, 3. So we will return I. So the maximum number of children that we can able to satisfy is 3. So I think you understand the algorithm. Let us try to do it in Python. So first of all, what we need to do, we need to take the input. So you can directly take the input or you can take from the user. So let me make like that, comma input dot split. So this syntax is for taking the input separated by spaces and it will be converted into list. Okay. Similarly, we need to do same for GS also. So let me copy the same here and paste it here. And let me change the name. So what we need to do here, we need to find the maximum number of children. Those are getting satisfaction, right? So let me define a function here. Let me call a function here that is maximum. So let me define the function with the parameters G and S. So at initially what we have done, we have sorted those arrays, right? So G dot sort and S dot sort. And then what we have done, we need to take their lengths, right? So N is len of G and M is len of S. And then what we have done, we need to consider two pointers. Let me initialize those pointers as 0 because both are at index 0 only at the initial stage. And then we need to do this while loop. While I less than N and J less than M. What we are checking, if what we are checking here, S of J is greater than or equal to G of I, what we will do, we will increment both the pointers. So if the condition fails, we will increment only one pointer. Okay. At the end, we will return what we will return I, right? So let me try to print here. So if it is syntactically correct, it should work fine, and we should get, okay, we need to take the inputs, right? So those inputs are 1, 5, 3, 3, 4, 4, 2, 1, 2, 1, 3. So answer is 3. You can try with another inputs also, and you can analyze this algorithm so that you can understand in a better way. So this is the second problem where we need to find the difference of sum of all the corners of a square matrix and its trace. So let us try to understand this. For example, we have a square matrix like, let me consider a 3 by 3 matrix here, and the elements are like 1, 2, 3, and 4, 5, 6, and 7, 8, 9. Okay. You see, here what we want to do, we need to find the difference of sum of all the corner elements. What are the corner elements here? 1, 3, 7, 9. Okay, what is its sum? 7 plus 3, 10, 10 plus 10, 20, right? And what is trace? Trace is nothing but sum of all the elements of diagonal elements. What are the diagonal elements here? 1, 5, 9. What is its sum? 15. So we need to return the difference, means 5 is the answer. So the problem here is to find out the exact position of corner elements and the diagonal elements. If I represent them, what is this element position? 0, 0 and 0, 1 and 0, 2 and 1, 0, 1, 1, 1, 2 and 2, 0, 2, 1, 2, 2. So what are our corner elements? 0, 0, 0, 2, 2, 0, 2, 2. So for any size of square matrix, for example, it might be 3 by 3 or it might be 4 by 4 or it might be 5 by 5. Only 4 corner elements are present. In those 4, first 2 corner elements are in the first row and second 2 corner elements are in the last row. So 0, 0 is the corner element for any type of matrix will be common. Now 0, 2. What is 2 here? Len of how many number of rows are there here? 2. So number of rows minus 1 is the value of 2 here. Means if I equal to 0, and j equal to number of rows minus 1 and minus 1. So that is the condition for getting this element. So what will be the condition for getting this element? Obviously I equal to n minus 1 and j equal to 0. For this one I equal to n minus 1 and j equal to n minus 1. So in this way we can get the four corner elements. Now let us try to find these diagonal elements. If you observe, this is 0 0 and this is 1 1 and this is 2 2. Means if I equal to j, that element we will call it as a diagonal element. So with this concept, let us try to solve this. So let me take the input from the user, like number of rows he wants. Of course, in square matrix, the number of rows equal to number of columns. So it is enough even if you take number of rows. Number of, like it is better to ask order. Enter the order of matrix. Now what we need to do is we need to take a list and assign it with the zeros, and then we will fill those zeros based on the input given by the user. So what we will do, we will assign them with zeros for I in range of row, for j in range of row. Let me print the L ones here so that you can understand. 4. You can see all the elements are filled with zeros. Now what we will do here is, for I in range of row, sorry, for j in range, since rows are equal to columns, let me use the same variable here also, since it is a square matrix. So we have already discussed some conditions, right, for finding the corner elements and trace. So let me define two variables here, like corner sum. Let me initialize them with zeros, and trace. So if I equal to 0 and j equal to 0, or I equal to 0 and j equal to row minus 1, or I equal to row minus 1 and j equal to 0, or I equal to row minus 1 and j equal to and j equal to row minus 1. If these conditions are happen, then our corner sum need to be updated, right? Corner sum plus equal to L of ij. So let me check whether are there any syntax error or not. Okay, there was a syntax error here. Okay, now it's fine. So what is the condition for diagonal elements? Phi equal to j, we need to update trace, right? Trace plus equal to L of ij. At the end, we need to print corner sum minus trace. Okay, we are getting 0. Okay, we haven't take the input from the user and we haven't take the elements, right? So let us do that. We have created a two-dimensional array by filling with them zeros, but we haven't collected the actual inputs from the user. So let's do that. For I in range of row, for j in range of, so our L of ij should be updated with the user input. Okay, so let me print here a message called enter the matrix elements. Okay, let me check once. Enter the matrix elements. Okay, 1 2 3 4 5 6 7 8 9. Okay, perfect. It is giving the difference 5. I have given the same elements that we have discussed in the example, that is 1 2 3 4 5 6 and 7 8 9, and the answer there we have is 5, and here also we have 5. So in this way we can able to solve this problem. So the next problem is where you will be provided a string where you need to identify certain keywords like info, warning, critical error, and you need to identify the count of them. So let's try to solve this problem. So here is the sample string I have taken. So first we need to traverse in the string for le in s dot split. If I use its split function, let me tell you, by printing the le once, so we can get the elements separated by spaces. Okay, now what we want to do, we know we want this info count and warning count and critical count and error count. So let us define those variables here. Info count as IC and warning count, let me initialize them with zeros, and the critical count will be 0 and error count will be 0. Okay, if ELE equal to what was that info, right? Then our IC will be incremented. If ELE equal to warning, what will be incremented? Our WC will be incremented, right? If ELE equal to critical, our CC will be incremented, right? Again, you need not to again check for these. If ELE equal to info, you can directly use the count function that is available in Python. But to understand the logic and to improve the skill, I'm saying like this. And if ELE equal to error, our AC will be incremented by 1. Okay. Let us try to print them so that we can check if there is any error or not. Let me print IC only. Okay. Now what we want to do, we need it in a dictionary format, right? So let me define a dictionary here, and the key is the keywords they have provided. Info, we need to assign info count here, warning, and we need to assign WC here, critical, we need to assign CC here, and error, we need to assign EC here. Okay. Let us try to print this dictionary here. So this is what they are expecting from us and from this program. So in this way we can approach this program. Okay, there might be various logic to solve this problem, so this could be one of them. In this question, you will be given a string and you need to identify the common characters in that string and you need to get the print count of those characters. So let us try to solve this problem. So let me try to iterate over the string character by character. So for that, let me use this loop. I need not require any space. If the element is not space, what I will do is I will take a separate dictionary here. If it is not space, I will consider that element as a key and I will append the count. Okay. Now let me try to print the dictionary once. Okay, it is fine, but we don't want the characters whose count is less than 2. So let us handle this one. So we will print if and only if the value is greater than 1. We will print corresponding key comma value. So in this way we can approach this problem. Now let us see the second problem here. In this problem, we need to identify special words. A special word is something, if any word that contains more than two vowels, then we call it as a special word. Okay. So they have given an example string here. Let me take that string only. So let me split the string so that I can get word by word. Let me print this L once. Okay, this is fine. Now what we should do is we need to identify the word by word and search for vowel count greater than 2. Okay, but try to print this really, what we will get? All these things. In order to search for the vowels, we need to search for the characters. Means again we iterate through this ELE. So for that, let me use another loop here. For C in ELE, if C equal to A or C equal to E or C equal to I or C equal to O or C equal to U. Okay, if it is that one, what should we do? We should increment the count, right? We haven't declared the count, but let us declare the count. Okay, if count is greater than or equal to 2, okay, it is more than, we need to print that corresponding word. A word in the sense our element, right? Okay. After printing that, we need to assign count as 0. Now let us see. You can see these are the, what are those special words in this string. So in this way we can approach this problem. So these two problems they have asked in the oral interview.
Thank you for watching this video. If you really like this video, please do subscribe to this channel so that it will motivate me to make more videos.